Bismillahirrahmanirrahim. Welcome to the Structural Engineering Software Application class, lecture number 15, and this is last lecture of the course. Okay, in today's lecture, I will discuss about the application of Seep feature of Geostudio. Okay, the lecture outlines are objective of the lecture, application of Seep example on steady-state seepage analysis by using Seep feature of Geostudio, and class task is given for student practice at the end. Okay, lecture objective. By the end of this lecture, the student will be able to perform underground water flow or seepage analysis to different structure by using Geostudio. Application of Seep Seep is a powerful finite element software product for modeling and analysis of groundwater seepage and excess pore water pressure dissipation problem within porous media such as soil and rock. Seep comprehensive formulation allows you to consider analysis ranging from simple saturated steady state problems to the saturated unsaturated time dependent problems. Seep can be used for analysis and design of geotechnical, civil, hydrogeological, geoenvironmental, and mining engineering projects. Seep support a comprehensive list of boundary condition option including total head, pressure head, flux rate, and flow rate. Seep can model almost any groundwater related problem including steady state seepage analysis of embankment, dewatering design for seepage into excavation, hydraulic response of a dam to a water level fluctuation, changes in pore water pressure condition within earth slopes due to infiltration, pounding of groundwater table beneath the water retention structures, effect of subsurface drains and injection wells, drawdown of water table due to pumping from aquifer, infiltration, evaporation, and transpiration from man-made or natural system. Now, example on steady-state seepage analysis. So, I will consider the embankment dam example given in this slide, right? And I will perform the steady-state seepage analysis through this embankment dam by using Seep feature of Geostudio. Okay, the following methodology will be adopted for steady-state seepage analysis of embankment dam. In definition view, the following 8 different steps involved like new project, define analysis, set view grid preferences options, sketch axis picture line or draw region, then define and draw materials, then define and draw boundary conditions, and the last step in the definition view is draw mesh property, right? When step 1 is completed, then we will switch to step 2 where we will solve the problem, and step 3 we will check different result. Now I will discuss each step in coming slide one by one. Okay, step 1 is to create a new project. When you open your Geostudio software, so from here you will click on the new, right? So this window will appear. From here you will set your page size, then click on create. Okay, in step 2 we will define analysis type, right? When you create a new project, so it will redirect you to this window, right? In this window you can add your new analysis type from add option, and you will add Seep analysis, and we will choose steady state. When steady state analysis type is entered or defined in the analysis, so it will be appear in this list, right? Here we can change the name of the analysis type, and we can define or we can enter the description of this project or this analysis, right? And from here we will just only choose the water transfer because we are performing the seepage analysis only. Okay, in define analysis window, so there is another tab of water. When we enter on the water tab, so the following different information will appear. So here we can change the maximum number of iteration and some other information. Okay, right, we can enter the physical constant like unit weight of water and bulk modulus of pore fluids. Okay, similarly, in the setting tab of define analysis, we will set analysis dimension to 2D, that is 2D dimensional. Okay, once analysis is defined, then we will set grids and units, right? For that, go to view and first of all set your units, right? And we will set the unit length in meter and mass will be in kg and forces will be in kilonewton. Similarly, we will set the grids spacing. For that, go to view and click on grids. So this window will appear. From here we can set the grid spacing along x and y direction to 1 meter. Okay, step 4 is to sketch axis. For that, go to sketch, then choose axis. So this window will appear. In this sketch axis window, you can set the x-axis and y-axis minimum and maximum values. As per the example, we will enter minimum 0, our maximum will be 55 meter, and increment size along x direction will be 5 meter. Similarly, set your values for y-axis. So minimum will be 0 and maximum will be 12 meter and increment will be 2 meter. And similarly, from this window we can change the orientation of x and y direction. For example, if you want to sketch axis of this format, for this case you will choose this option and this elevation option, right? Similarly, we can also add axis in this orientation. In this case, you will choose this elevation option and you will choose distance option. So it will draw axis in this orientation. And any other kind of orientation, you can choose your axis title accordingly. We can also sketch picture. Okay, we can bring picture into our drawing area as a reference for sketching or drawing a region or line. For that, go to sketch, then click on picture. So this window will appear. From here you will add any picture and you will go to browse or where your picture is placed. So from here you can add the picture when you choose it and then close, so it will be appear in the drawing area. And if you want to delete this picture, you choose that picture from the list, then click on the delete, so it will be deleted. Now we will sketch the embankment dam geometry. For that, go to sketch and then choose line command, right? So this window will appear. From sketch line window, we can enter any line by defining its x and y coordinates. So first of all, we will determine the different points x and y coordinate given in this table. For point 1, the coordinates are 0, 0. Similarly, for point 2, the coordinates are 24 and 12, right? In order to draw this first line, we will enter point 1 coordinates 0, 0 and point 2 coordinates 24 and 12. Similarly, we can sketch other line by entering the x and y coordinates accordingly. I will sketch water reservoir level, right? Again by using the line command of sketch, right? And I will enter the line x and y coordinates here to draw water reservoir level. Now step 5 is to draw a region. For that, go to draw and click region. So this window will appear. In the example, we have only one region, so we will specify different point for this particular region. So we have 4 points for this one region. So we will choose all the 4 points and draw the region. Step 6 is to define and draw materials. So first of all, we will define a material. For that, go to define, then click on material. So this window will appear. So we will define the embankment fill, right? So we will add the material embankment fill, and then we will choose the hydraulic property material model will be saturated and unsaturated. We have some other model as well, like saturated only, but we will use here saturated and unsaturated model. And then we will define volumetric water content function, and then we will define hydraulic conductivity function. Right, so first of all we will define volumetric water content function. For that, click on this option, these three dots. Okay, when you click on the volumetric water content function, so this another window will appear. So from here we will add a new function with the name of fill volumetric water content function, right? And then we will choose the types volumetric water content data point function from the list, right? And then we will click on the estimate, right? So this window, another window will appear. From here we will choose the estimation method will be simple function, and then we will define saturated water content, that is 0.5, and the simple material is, let's suppose, silt, right? And I will keep the rest of value remain by default, and then click on OK. So this fill volumetric water content function will be estimated like given in this diagram, right? And the value for that is given here, right? We can also edit different data points, and we can change the x and y coordinate in the form of log or linear, right? And from here we will enter the compressibility coefficient, and we will enter the value 0.0005 per kilopascal. Here the volumetric water content function is defined. Now next we will define hydraulic conductivity function. For that, click on the hydraulic conductivity function. So this window will appear, right? From here we will add a new function, and we will change the name fill hydraulic conductivity function or K function, right? And from here we will choose the type of function, that is hydraulic K data point function, and then we will click on the estimate. So we will use the estimation method, and then we will choose the volumetric water content function that we have defined previously, and then we will enter saturated Kx value, that is 10 raised to power minus 6 meter per second, and then we will enter the residual water content, that is 0.05, right? And then click on OK. So it will give us the hydraulic conductivity function, right? And this is the value, the data of this function, right? Once both functions are defined, then we will choose the volumetric content function from here, and similarly we will choose the hydraulic conductivity function that we have defined. Okay, both functions are defined here. Similarly, if the material is anisotropic, so we can enter the Poisson ratio, that is Ky by Kx ratio. So we will enter any value. If it is isotropic, so we will enter one value, right? Okay, once material is defined, then we will draw the material. For that, go to draw, then click on the materials. So this window will appear. From here we will choose the embankment fill material, and we will assign that material to the particular area. Okay, step 7 is to define and draw boundary condition. For that, go to define boundary conditions, right? So for drainage and zero pressure, boundary condition is there as by default. So when you click on the drainage boundary condition, so it will give you this data, right, where the boundary condition type is constant and having zero value. Similarly, in case of zero pressure, so it will give you the boundary condition type constant and having zero value. So here we will define a boundary condition for reservoir, right? So the reservoir we will add a new boundary condition, click on the add, right? And we will add reservoir, and we will choose the kind of value will be water total head, right? And the boundary condition type will be constant, and the height of this reservoir is actually 11 meter. We will enter 11 meter here. Then we close it. So the boundary condition is defined. Okay, once the boundary condition are defined, next to draw boundary condition, for that go to draw, and then click on the boundary condition. So this window will appear. From here we will choose where we want to apply a boundary condition. So in this case we want to apply boundary condition to a line, so we will choose line from here, and then we will apply a drainage boundary condition at this downstream side, right? We will assign it here. Similarly we will assign the reservoir boundary condition at this location, the upstream side, right? And then okay, step 8, and that is the final step in the definition view, is to draw mesh property. For that, go to draw and then choose mesh property. So this window will appear. From here you will choose the region where you want to assign different meshes, and you will specify the maximum or approximate global element size here, that is 1 meter, and we will choose the mesh type, that is quads or quadrilateral or triangles, right? So the meshes will be assigned to the given region. Okay, this is the final model, right? And it is ready for analysis. For that, go to window and click on the solve manager. So analysis will be started. When the analysis is completed, so we can display different results, and we will switch to step number 3, that is a result view. So when the analysis is completed, this will directly give us the result of water flux, that is the volume per unit area per unit time of water, and it is represented by arrows, right? And this is the reservoir head level. Similarly, we can display other results, like we can draw label contours of total water head, right? For that, go to draw, click on the contours, and from there you can choose total water head. So it will give you the total water head contours, right? And this is the value of water total head. Similarly, you can draw contour of water pressure, okay, and also we can display water pressure head, and we can also draw flow paths. For that, go to draw and choose flow path and click on the embankment fill. So it will draw the flow path accordingly, like this, right? If you want to delete a particular flow path, so you just click on that, so it will be deleted. And we can also draw iso lines. It is a line having peak values, right? So for that, go to draw and click on the iso line. So this window will appear. From here we will click on the water pressure and change the other parameters from here. So the iso line or the peak water pressure line will be drawn like this. And you can also draw a graph. For that, go to draw, then click on the graph. So this window will appear. We can draw a graph between different parameters, like in this case the water x conductivity and metric section, and we can add the other multiple graph as well, having different x and y parameters. And we can also show object information. For that, go to view, then click on the object information. So this window will appear. From here we will display the different information of the object, complete information including the materials and the other property. You can also display result information for our different roads. For that, go to view and then click on the result information. So this window will appear. From here we can specify in the form of nodes, and we can change the data category to all, or we can check the data or result for a specific node as well. Okay, now again I will consider another example by using the previous example data, right? Where if there is drain at downstream side, right? This is the previous example, and let's suppose here there is a drain. How we can model this drain as well? So for that, again go to definition view, because we will define another analysis for this toe drain. Move back to definition view, then click on the define, then analysis, right? So we will add another analysis, but here we will add clone. It means that we will reuse data of previous example, right? And define the analysis definition, we will keep all other value as same as we have discussed in the previous example. Okay, for drain, What we will do, we will draw a point, right, where we can draw or locate a drain. So we will draw a point. For that, go to draw, then choose point. From here we will add point at this location having 45 and 0 coordinates. Okay, once the point is created, then we will draw a boundary condition for this drain. For that, go to draw, then boundary condition, and we will choose the 0 pressure boundary condition here, right, and we will select the line and we will assign this boundary condition drain location, and then we will draw mesh properties for this drain. For that, go to draw, then mesh property, and then we will select this drain line, and then we will generate mesh in the form of length, that is 0.5 meter, right. So by this way the drain mesh is created. Okay, once the drain line is mesh, then we can solve the model. It is completed, right. Then we can display different results like water total head. So it will represent the drain here. So all the water or the peak flow will be to the drain. It can be seen over here. Okay, finally we can set the page layout. For that, you can choose the page layout option, right. So this window will appear. From here we can set the size of page and some other information given in this slide. Now let's see how to solve this example in Geostudio. Okay, when you open your Geostudio software, so this window will appear, right. So first of all, we will create a new project. For that, click on the new, right, and then set your page size Imperial A4, then click on create, right. So this define analysis window will appear. Here we will define the project name. Let's suppose this is project 2, right. Then we will add analysis type, that is the Seep analysis, and it will be steady state, right. So the steady state seepage analysis is added in the project 2, right. So from here we can change the name of this analysis, right. We can also change the analysis type. Okay, in the physics analysis view or tab, we will choose the water transfer, and in water tab we can change the unit weight of water and bulk modulus of pore fluid, or we can also change the other values, but we will keep the other value as is by default. Then we will switch to the setting. From here we will choose the analysis dimension 2D, right, and we can also set the starting time or duration, right. So the analysis is defined. Then close this window. Now next step is to set your unit and grids. For that, go to view, units. So I will change the length unit to meter and mass into kg and force into kilonewton, and I will set the grids spacing. For that, go to view and click on the grids. So I will keep spacing along x and y direction 1 meter, right. Now I will sketch axis. For that, go to sketch, then choose axis. So this window will appear. From here I will define the minimum and maximum value along x and y direction. So let's suppose I will keep along x direction, and I will enter minimum value is, let's suppose, -5, and maximum is 55, right, and I will change the increment size to 5, and here I will define the minimum along y direction is -2 and maximum is, let's suppose, 12, right, and increment is, let's suppose, 2, right. So the X is created. Okay, as I told you in the lecture, then we can change the orientation of X or Y axis. For that you will choose the relevant option. You can also add your axis in all four direction, right? As per your requirement, you can also set your axis in this way. Step is to sketch line. In order to draw the geometry, for that go to sketch, right? Then click on line, right? Then specify the X and Y coordinate for point 1 and 2 for each line. So first line is at location 0 0, and the second location is 24 and 12, and the second line location is at 24 12, and the second point at 29 12, and third line is located at 29 12 52 0, right? And the last line is located at 52 0, and the second coordinate is at 0 0. Clear? So the geometry is sketched accordingly. Then next we will draw a line for water reservoir. For that again click on line, sketch, right? For the water reservoir, the line coordinates are 22 11 0 11, right? So the water reservoir is drawn. Now we will draw a region. For that go to draw, then click on region, right? And then we will specify the different point for the region. This is point 1, point 2, point 3, point 4, and this is the final point, right? So the region is drawn. Now next step is to define materials. For that go to define, then click on materials. So here we will add embankment fill material, right? And from here we will choose saturated and unsaturated model, right? So first of all we will define volumetric water content function. So we will click on this 3 dots. So we will add new function and change the name from here, volumetric water content function, right? And from here we will choose the type volumetric water content data point function, right? Then we click on estimate, right? From here we will enter the saturated water content, and that is 0.5, and the materials is silt. Click on OK. So it will give you the fill volumetric water content function. So from here we can change its value to x log and make it edit data points, right? So here the function of volumetric water content is defined. From here we will change the compressibility coefficient, that is 0.0005. Then click on close. So the volumetric water content function is defined, and we will choose it from here. Then next we will define hydraulic conductivity function. For that click on these 3 points, then add new function, and it is fill k function. So from here we will choose the hydraulic k data point function, right? Then we will click on estimate. So from here we will choose the fill VW water content, that we have already defined, and from here we will enter the k value, that is 1 e power minus 6, and here the residual water content is 0.05. Click on close. OK. So the function is defined, and change the edit point data and change it to x log and then edit point data. So the function for k fill value is defined. Okay, and if you want to copy this graph data, or you can also copy this graph image as well. Click on close. So hydraulic conductivity function is defined. From here we can choose it, right? So we will not consider in isotropy, so we will keep ky by kx ratio equal to 1, and when material is defined, then click on close. Now we will draw this material. So for that, go to draw and click on materials. Okay, then click on the region where you want to assign this material, right? So material is drawn. Okay, next step is to define boundary condition. For that, go to define, then click on boundary condition. So the drainage and the zero pressure boundary condition is already created as by default. We will enter only a boundary condition for reservoir, right? And we will choose a water total head, and from here we will enter the height of this water level, and it is 11 meter, right? And we can set the color of this boundary condition, right? And then click on close. So the boundary condition are defined. Now next we will draw boundary condition. For that, go to draw, click on the boundary condition. So first of all we will draw the reservoir, and for that we will choose a line. So we will assign this boundary condition to this line, and we will assign drainage boundary condition to downstream sides, right? Boundary condition are assigned. Now next step is to draw a mesh property. For that, go to draw and then click on the mesh property, and from here choose the mesh region, and we will change it to 2, right? Or we can also make it 1, right? And we will choose quads and triangles option from here. So the meshes are drawn. Now the model is ready for analysis. Then we will click on start analysis, and then we will save it, the file. Okay, analysis is completed. Now we can display different results. Okay, it will directly give you the water flux result in the form of arrows. We can display other result like water total head, and we can display pore water pressure contours, and we can display pressure head as well, right? So we can remove this arrow, that is the water flux arrow, from here, right? Similarly, we can add legend of different responses. For that, go to draw contour, right? From here we can show legend of a particular parameter, right? It will give you the water pressure head at different location, right? The color represent the value of water pressure head. Similarly, we can make it none. So we can also draw flow paths. For that, go to draw and then click on the flow path, and then click on the region, right? So it will give you the flow path. If you want to delete a specific flow path, for that, click on this flow path again to delete the flow paths, right? Similarly, we can draw iso lines. For that, go to draw, then click on the iso lines. So this window will appear. From here you will add another one, for water pressure, right? You can check over here, so it is drawn, right? Similarly, we can draw different graphs. For that, go to draw, click on the graph. From here we can draw a graph between any parameters, right? So this graph is between metric section and water X conductivity. Okay, this is all about steady state seepage analysis in embankment dam. Now I will consider the second example where we will consider the drain at this toe level, right? For that, again go to definition view, right? Then define another analysis, go to define and click on analysis. From here we will add clone of this example, and then we will change the value of this analysis type to steady state seepage analysis, seepage drain, right? So the rest of value will be remain same, then close it. Okay, next step is to draw a point where we can specify the drain location. For that, go to draw, then click on the points and then specify point in this location, right? So point is added at the start of the drain. Now next step is to apply or draw a boundary condition for this drain. For that, go to draw, boundary condition. So the boundary condition for the drain will be zero pressure. So apply the boundary condition here. Now next is to mesh this area where we will assign. We have already assigned the drain. So for that, go to mesh property, right? Then we will select the drain portion, right? And from here we will use the length of, and we will enter 0.5, right? So this portion is meshed, right? Now we can run analysis for this particular example. Okay, analysis completed. Now we can display different results. If you want to display water total head, so here it will represent the water total here. If you want to draw a flow path, so click on the flow path, right? So in this analysis result, the flow path is converged toward. Similarly, we can draw a iso line, right? And it is also converged toward the drain area, right? So this is all about example of seepage analysis by using Seep W feature of Geostudio. Now class practice task: perform steady state seepage analysis for embankment field given in this slide, right? And the different materials and the other dimensions, property or values are given. So thank you so much. This is all about lecture number 15.